Assalamu alaikum, dear students. Today we have a topic of chapter number 18. So, this is the first topic of chapter number 18 in our smart syllabus. The topic number is 18.2, Special Theory of Relativity, presented by Albert Einstein in 1905. Okay. So Einstein formulated this theory of relativity on the basis of the following 2 points. The first point of Einstein theory of relativity is the speed of light in vacuum is same in all inertial frames. In all inertial reference frames, irrespective of the motion of the source or observer. So this is the first point of the Einstein special theory of relativity, that the speed of light in vacuum is constant in all frame of references, irrespective of the motion of the source and observer. The speed of light in vacuum is 3 into 10 power 8 meter per second, and this speed of light will be constant in all frame of references. Okay, now the second point is the laws of physics. The laws of physics are same in all inertial frame of references. In all frame of references. Okay. If we talk about the laws of physics, so first we have to consider the classical physics and the modern physics. Okay, so come towards the classical physics. Classical physics is an old type of physics which were discovered by Newton, so that is called the Newtonian physics. It is the study of macroscopic objects. Okay, macro mean larger objects that we can observe by naked eye, that is a microscopic objects, and these macroscopic objects have low speeds, and classical physics is valid in inertial frame of reference. What is meant by inertial frame of reference? Inertial frame of reference mean the frame of reference in which there is no acceleration, means the velocities of the objects are same with respect to one another. That is called the inertial frame of reference. It means we can call them an isolated system, that the net force in this system is zero. So if the net force is zero, so the net acceleration will be zero. So if the net acceleration is zero, the velocities of the objects will be constant with respect to one another. So this frame of reference is called the inertial frame of reference. Okay, so there should be inertial frame of reference. Okay, and energy is to be considered is to be considered as continuous form. Continuous form means wave form. So energy is to be considered as wave form. Okay. Means we have to discuss the interference of waves in classical physics, diffraction of waves, dispersion of waves, etc. These are the properties which shows the wave nature of energy. So in this physics we have to study those properties which supported the wave nature of energy. So here energy studies as waveform, means continuous forms. Okay. And classical physics say that the space means the displacement, the velocity, the position, the velocity, the position, the acceleration, the force, acceleration, that these all terms etc. are relative. These all terms are relative terms. Relative terms means they depends on the frame of reference. They depends on the frame of reference or the observer. So it means, so these are changing with the motions. These things are changing with the motion, but time, mass are absolute. Absolute means they do not depend upon the frame of references. They do not depend upon the observer. It means the observer is moving or the frame of reference is moving, the time will not changing. The time will be constant as it is passing in the watch. So this time will not be changed ever if the frame of reference is moving or the observer is moving. So time will be constant and mass will also be constant. So these are called absolute quantities. Absolute quantities means which changes with the frame of reference. Absolute quantities means do not change with the frame of reference, which do not change with the observer. So it means, so time and mass are absolute according to the classical physics. Now another thing is modern physics. In modern physics, this is called quantum physics because it is discovered by Planck's in a Planck's quantum theory. So this is also called quantum physics. Okay. So here we study the microscopic objects. Micro means small objects. And we know that in microscopic objects, the speed of the microscopic object will be very high speed, very high, approachable to the speed of light. Approachable to the speed of light, this speed is very, very high because the objects are very small, so their speed are very high. Okay. Now here this is also valid. It is also valid in inertial frame of reference. What is meant by inertial? Inertial means there is no net force, there is no net acceleration, the velocities frame of reference, the velocities of the object will be constant here. So this is called inertial frame of reference. Okay. So it is valid in inertial frame of reference, and the energy here is studies in discrete form. Here the energy is studied in discrete form. Discrete form means packet form. Packet form means quanta form. quanta form. So here the energy studies in discrete form. So the energy we call it photon. Photon. What is meant by photons? Photon means energy packet. Photon mean energy packet. So here the energy is called photons. Photons mean the energy packet. Okay. And we will study reflection here because particle can be reflected. So we will study scattering because particle can be scattered. Here we will study refraction because particles can be refracted. So we will study those properties of energy which supported the particle nature of light. So that is why we will study these properties. Okay. Now, modern physics say that the time, the mass, the energy, force, acceleration, velocity, displacement, all these things are relative terms. All these are relative terms. Relative means which changes with the motions, which changes with the motions, which changes with the frame of reference, which changes with the observer. So these are the relative terms. But speed of light is absolute. C means speed of light. Speed of light is absolute. Absolute means which do not depend upon the frame of reference, which do not depend upon the observer. That is called the speed of light. Okay. So in the first point of special theory of relativity, it is said that the speed of light will be constant in vacuum in all inertial frame of references, regardless of the motion of the source or observer. Means it is not depending upon the motion of the source or observer. Okay. Suppose in classical physics we say that suppose this is mass m1 is moving with speed v1 and this is mass m2 speeding with speed v2, and the relative speed of them will be v1 minus v2. This is the relative speed of these two masses in classical physics. But here Einstein said that the speed of light is constant. Speed of light is not depending upon the observer, not depending upon the frame of references. So here, suppose if two photons are moving with the same direction, suppose one photon is moving with c, another photon moving with the speed of c, both are moving towards right, so their relative speed will also be c. So it means the photons are not relative, these photons are absolute. So photons are absolute, these are not relatives. If two masses in classical physics moving in opposite direction, suppose m1 and m2 are moving opposite in direction, so their relative speed will be v1 plus v2. But here in case of photon moving with speed c, another photon moving with speed c, so their relative speed is also c. So it means the speed of light is not depending upon the frame of reference or the observer. The speed of light is always constant. Another meaning of this point is that the speed of light will be constant in vacuum. In vacuum mean in a single medium. If the speed of light is moving in air, in vacuum, suppose if we talk about the vacuum, so the speed of light is moving in vacuum, so at each and every point the speed of light will be constant, that is 3 into 10 power 8 meter per second. Okay. Now if the speed of light is moving in air, so the speed of light at each point will be constant, that is 2.99 in 10 power 8 meter per second. Suppose if the light is moving within the water, so the speed of light at each and every point will be constant, that is 1.5 into 10 power 8 meter per second. So here in vacuum, at each and every point the speed of light will be constant. In air, at each and every point the speed of light will be constant. In water, the speed of light at each and every point will be constant. But if we compare with one medium to another medium, the speed of light will be changed, but in a single medium, it will be constant. So it means that the speed of light in a homogeneous medium will always be constant. So that is the first point of Einstein's special theory of relativity. Now the second point is all laws of physics. All laws of physics mean the classical laws and the modern laws of physics will be constant in inertial frame of references. Okay. In the principle of relativity presented by Galileo in Newton's first law, it was stated that it is impossible to perform an experiment with an inertial frame of reference to detect the motion of the frame of references. The only way to detect the motion of an inertial frame of reference is by referring to another frame of reference. For example, if you are sitting in a spacecraft far away from the planet, we know that our planet is Earth, and if you are sitting in a spacecraft which is very far away from our planet, okay, then you cannot observe from the spacecraft that we are moving on the Earth. Means the motion of the Earth cannot be observed. The motion on the Earth cannot be observed from the spacecraft, because over there the frame of reference is moving. So according to the Galileo's physics, according to the Galileo theory, the frame of reference should be kept constant, should be kept at rest. It means if the observer is moving, so if the observer is moving, if the frame of reference is moving, then we cannot observe an event, we cannot observe an experiment. Okay. So it means that if you want to observe the motion of the Earth, so you should sit on the Earth, so your frame of reference will be the Earth. So you will observe from the Earth. Okay. Imagine you are sitting in a train. You are sitting in a train. Suppose this is a train, and the person is sitting in a train. The train is moving towards right. Okay. And these are the two doors. These two doors initially is closed. So suppose if the doors are open, so it will be moved towards this door will be moved towards left, and this door will be moved towards right. So these doors are open. Okay, these doors are sliding. So if the door slide towards inward to the person, it means they are closed. If they move away from the person, it means they are open. Okay. The passenger is sitting in a train. Okay. Now the train is moving towards right. Okay. Now another person sitting on a platform, he is observing the train which has two doors which are open. Okay. Now as the train coming towards left, when the train is coming towards left, during the motion, this passenger observed that the two doors are get closed. The two doors are get closed. So it means if this door is want to get closed, so this door should move towards left, so it will be closed, and this door should move towards right, so it will be closed. So this passenger said that both the doors are closed at the same time. So this passenger said that both the doors are closed at the same time. But this passenger said that no, both the doors are not closed at the same time. This door is closed earlier than this door. Means this door is closed later on, because here everything in our world is relative except speed of light. So the train of the speed is towards left, and this door is moving towards right. So it means their speed will be added. So this door will be closed very fastly with respect to this person. And here the speed of the train is towards left. So here this door is moving also towards left. So both have the same direction. So it means this passenger observed this door will be closed later on. Okay. So now everything in the world is relative except the speed of light. This is stated by Einstein, that the speed of light is absolute quantity, it will not be changing. Okay, so if you want to observe some phenomena, you should be in inertial frame of reference to that phenomena so that you can observe it. So if you observe the classical physics, if you want to study the modern physics, you should make sure the inertial frame of reference. In inertial frame of reference, these laws are valid and accurate. Okay, this is all about special theory of relativity. Now we are studying the consequences of special theory of relativity in another topic. Okay, take care. Allah Hafiz.